You recognize the song, it's Danger Zone from Top Gun. Now you might ask, what in the world does Top Gun have to do with the math that we're doing? Well, we're going to be doing a simultaneous solution of two or more equations. Given that objective, it's kind of like the battles that they had in Top Gun. Over here, I have Tom Cruise Maverick. Over here, I have Jester, the school instructor, and they're practicing aerial combat. The objective is to line up and eliminate your enemy. I guess I said it backwards. This would be Jester and that would be Tom Cruise. Well, at any rate, what has this got to do with it? We're going to be given two equations. And when we have those two equations, they will intersect in one point or multiple points. And for us to find that solution is very similar to this. Now, consider this ordered pair. We want to determine, is this a solution to that? Okay, well, what we do is we one at a time take the X value and put it in here and put the Y value in this equation and see if indeed it's equal to 24. Well, it is. Then we do the same thing with the second equation. So here's our substitutions, okay? -3, 5 times 5, is it? Uh-oh, no. What that means is this point is not where those two lines would intersect or share in common. Now, that's the process of determining, is an ordered pair a solution to the system? Notice that language. This will be on my test and the final. Okay, here's another one. Will this ordered pair work with both of those equations? Well, let's try it. Here we try the 0, 1/2 in the top equation, it works. We try it in the bottom equation, and it works. What that means is that this is indeed the point where those two equations the lines from those equations would intersect. And I'll wait on the clock. Okay, we've got these two equations. Here's some of the language. System of two linear equations in two variables. Solution set of the system is any ordered pairs that make both equations true. In other words, how do you check that? By taking the ordered pair and substitute it in to see. They are telling you that the 0.25 is a solution to this pair. And you can check it yourself to see if you want. We'll do just one of them. 2 times 5 is 10. Minus 5 is 5, so 5 equals 5. 4 times 2 is 8. Minus 5, 8 minus 5 is 3, so 3 equals 3. Yes, it is. Now, we look at these graphically, okay? Where they intersect is that point. So here's our two equations we had for a moment. If we graph these two equations, now we can either set up an XY table and plot points, or we can put these in y-intercept form and graph them from the y-intercept going upwards and outwards. Well, at any rate, here's the first equation. Here's the second equation, and they intersect in this point. Well, what is that point? 1, 2, 2, 1, 2, 3, 4, 5, 2, 5, 0.25 that we said it would be. This is similar to what my Top Gun analogy was trying to show. In other words, you have a line formed by the direction of the one aircraft and a line formed by the direction of another aircraft or a missile shot from the aircraft, and where they intersect is the solution. If a system of equations has at least one solution, they call it consistent. This is some language that might be used in problems, both in ALEKS and on tests. The word consistent simply means they have at least one point in common. Now, they could have more than one point, but if they have at least one point, we call it consistent. If they have no solutions, like parallel lines, then we call it inconsistent. If a system of two linear equations in two variables has an infinite number of solutions, then we call them dependent. Otherwise, they are independent. In other words, if the two different lines can exist completely by themselves, we call them independent. Now, by dependent and this infinite numbers of solutions, what that really means is these are actually the same line, just in a different form. And I'll give you examples of that in a moment. Okay. Identifying in two variables. There is one and only one solution. Okay. When you have that with intersecting lines, once again, if there's only one solution, like Top Gun and like the last example I did, we call them consistent. What if there's no solution? If the system of equations represents parallel lines, then they never intersect, so there is no solution. There's no point that'll work with both lines. And we call that inconsistent. And the third possibility, infinitely many solutions. If it represents the same line, then all the points on that common line satisfy each equation. Therefore, the system has infinitely many solutions. In other words, for every x value possible on that line, it has its own y value to go with it. It is consistent because there exists points, but they are dependent because since it's the same line, the x's and y's of one equation are dependent on the other. Okay. Here's an illustration of that. These two are consistent because they intersect somewhere, and they are independent because they exist independently. These two are inconsistent because they will never intersect, but they are independent because they exist uniquely. Now, this is really two lines piled on top of each other. In other words, actually the same line. And I'll show you in a couple of moments how that can exist. They are consistent because, yes, they share points. Here we shared a point. Here we don't share points, so inconsistent. But they are dependent because every point here of one line depends on the same point in the other line, and there are infinitely many points on that line. that are shared in common. Now, there are two methods of solving these algebraically. You can do it graphically, but the problem with graphics is if you have to deal with any fractions at all, then at best you're making an estimate. So we're talking about numbers. Any numbers, you can get an exact answer by either the addition method or the substitution method we'll cover in a few moments. Okay, the addition method and the elimination method are just interchangeable names. What we do is we eliminate one variable at a time by adding the two equations. If the coefficients of the variable are opposites, what I call an opposite pair, then that variable can be eliminated simply by adding the original equations. If they're not opposites, if you don't have an opposite pair of a variable, then it is necessary to multiply one or both equations by some number before we add. Okay, let's look at that. Here are two equations. Okay. I don't have an opposite pair here. In other words, -6 or +6 and +10x are not opposites of each other. Neither are 2y and 7y. So what we're going to do is we're going to multiply one or more equations by something so I get an opposite pair. In this case, they chose to multiply the top equation by 5 and the second equation by -3. So here's what we get. If we take 5 times the first equation, we get 30x plus 10y equals 20. Then we're going to take the second equation by -3. -30x minus 21y plus 24. Now, why did we choose 5 and -3? Well, to get a common term, if I look at 6 and 10, what are the possible numbers that both of these can go into? Well, 30 is the smallest number that both of these will go into. Okay, so we multiplied this by 5 to get 30. We multiplied that by 3 to get 30. We could have instead have chosen to get an opposite pair of y's. If that's the case, 14 would be the smallest number that both of these would have gone through. So I would have multiplied the top equation by 7 and the bottom equation by -2, or the top one by -2 and the bottom one by +7 or +2. -7, +2. You've got some flexibility. What way seems easiest to you? Well, in this case, they chose to make the x's the set of opposite pairs. So we're going to add these two equations. These x's cancel out. That leaves us -11y and leaves us equals 44. That's a simple equation we can solve, and we get the y equals -44. That means that this -4 is the y value of the point of intersection of these two lines. Now, to get since we eliminated the x value to start with, now we have to go back and find it. So we take this -4 and we put it into either one of the original equations. It doesn't matter which one. We chose the first one because the numbers are smaller, I think. So anyway, here's the equation, and we put in the value of y here. So we've got 6x plus 2 times -4 equals 4. 6x minus 8 equals 4. Divide both sides by 6, and we get x equal 2. So that means our solution then is the point to -4. Now, if you've got x's and y's in a problem, assume that they want you to make it a point and give your solution in point form. Now, if you add an a and a b, you would just say a equals 2b equals -4. Okay, more solving them. What they're telling you here is put the equations in the same order. Now, this is showing standard form, ax plus by equals c. If you had both equations in y equal mx plus b form, that would be okay. But both equations have to be in the same format before you do this solution. Then you create an opposite pair of coefficients for one of the variables. And then you solve for the other variable. So the final step, after we've got an answer for the first variable, then we substitute back in for the second variable. Let's look at an example, addition method. Here, I've got a 2 and a 5, greatest common or least common factor of these two would be 10. So I could multiply this by -5, multiply this equation by +2. If I wanted to eliminate the y's first, which is probably what I'm going to do because I've already got opposite signs, I would just multiply this equation by 3 because it's easier to just multiply this equation by 3 than it is that one by 5 and this one by 2 of opposite signs. So we're going to multiply that by 3, makes this first equation 2x plus 3y equals 10. The second equation now becomes 15x minus 3y equals -78. So I multiplied each term by 3. Okay. Well, we're going to add those equations. I'd prefer the 17x be under the x's, but here you have an opposite pair. So those two are going to give you 0. These two are going to give you 17x. This gives you -68. Very conveniently, 17 divides into 68 exactly. So your answer is -4. So that's an x value that presumably would go into both of these problems. Now let's take that -4 and put it into one or the other of these equations and solve for y. Okay, well, we could do it with this one. We got this 3 in front of it. We've got a singular y here, which would be easy, but we've got some signs to deal with. So in this case, they chose to use the second equation because the y was already a singular y. So they replaced the x. They took this -20 over to the other side. Okay. When they took the -20 over to the other side, they added 20 to both sides, leaving -6 over here and -y. So if -y equal -6, +y equal +6. So what that means then is we have the point -4, 6. So once again, what are the rules? If we don't have an opposite pair automatically, then we have to find what can we multiply to all of the terms of one or both equations to get an opposite pair. Okay, this time, this one looks a little bit ugly. We don't have an opposite pair anywhere. Here, we got multiples of 10. Here we got multiples of 3s. So that's numbers for us to consider. We've already got opposite sides here, so I'm probably going to deal with this equation. But first thing I'm going to do is I'm going to clear the decimals. Since I've got one digit behind, I'm going to multiply by 10, which makes this equation into 50x plus 3y equal 14. I've got one digit behind, I've got 2 digits behind. So I have to multiply by 100, making this 20x, making this 10x, making that 28. Now I can look at this and see what I need to do. Well, I can multiply this by maybe a -2 and a +5, or I can multiply this by 10 and by 3. So we're going to multiply that one by 2. In other words, we're going to choose to eliminate the x's. So this becomes 100x plus 6x minus 28. This becomes 100x plus 50y equals 140. We add those two equations because I've got an opposite pair here. Gives us 56y equals that. 56 divides into 112, -2 times. So now we take this -2 and substitute into one of the equations. Now, we could put that -2 into one of these decimal field things, but it's easier to use one of these two equations instead of one of those two in this case. So we're going to use this top one. Okay, so we've got 50x plus 3 times the -2 for y equals 14. Simplify it. 50x plus 6 or minus 6 equals 14. Add 6 to both sides, we get 20. And so we get x equals 2/5. See, this was one we could not use with fractions to get the, or with graphing to get the solution. So our answer then is, and 2/5 can be rewritten as 0.4. So our answer, since the original problem was in decimals, we're going to say our answer is 0.4 -2. Or it would be equally correct to say 2/5 -2. Another set of questions, this time we have fractions. We still got to find an opposite pair. This is where we will start tomorrow, and or not tomorrow, but rather on Thursday. So if you want to go ahead and write that down so you'll be ready to go on Thursday, I would encourage you to. But this is where we'll start on Thursday.